poisoned Python package came within one crashed developer machine of becoming one of the most catastrophic data breaches in AI engineering history. The litellm supply chain attack wasn't theoretical. It was live, actively exfiltrating credentials and only stopped by an attacker's own incompetence. This is the story every AI engineer needs to understand right now. The attack was remarkably comprehensive in its targeting. A single pip install command would silently harvest SSH keys, AWS credentials, Kubernetes configuration files, cryptocurrency wallet data, shell history logs, SSL private keys, and Git credentials. Essentially every sensitive secret stored on a developer's machine. This wasn't a narrow targeted attack. It was a total exfiltration sweep designed to hand attackers complete control over your cloud infrastructure. When a package with 97 million monthly downloads is compromised, you're not talking about isolated incidents. You're talking about a potential simultaneous breach across thousands of companies worldwide. To put that in perspective, that download volume means litellm touches a significant fraction of all active Python AI development environments globally. A silent, competent version of this attack could have handed attackers the cloud infrastructure keys to a generation of AI startups in a single deployment window. Here's the part that should genuinely unsettle you. The only reason this attack was discovered is because the attacker wrote inefficient malware that consumed so much memory, it crashed a single developer's machine. One developer, one crash, one curious person who investigated rather than just rebooted. If the attacker had applied basic optimization to their code, this campaign could have run silently for weeks or months, draining credentials from thousands of environments with no visible trace. The security industry calls this threat actor luck, and we were on the wrong end of it. The affected developer in this case never typed litellm into a terminal. They installed a cursor MCP plugin, and litellm came along as a transitive dependency, a silent passenger inside a package inside another package. This is the fundamental trust problem of modern software development. Your requirements file is just the first layer. Every package you choose has its own dependencies, which have their own dependencies, which can stretch 5 or 6 layers deep into code you've never read, reviewed, or even seen. You are implicitly trusting the security practices of dozens of strangers every time you run pip install. There is a brutal irony embedded in this story. Vibe coding, the practice of moving fast with AI assistants generating code and installing dependencies without deep review, is actively expanding the attack surface for exactly this kind of supply chain compromise. Developers are accepting more transitive dependencies faster than ever before. But in this specific case, the attacker apparently also vibe-coded the malware, producing a noisy, inefficient script that crashed machines instead of hiding silently. The lesson isn't that vibe coding saved us. The lesson is that next time the attacker will be more careful and we won't get that warning signal. First, pin your dependency versions and commit lock files. Floating version ranges are an open invitation for substitution attacks. Second, run pip audit or similar tools against your full dependency tree, not just your direct dependencies. Third, apply elevated scrutiny to any package that touches credentials, environment variables, or network I/O because those are the highest value targets for attackers. Fourth, audit what your MCP plugins and AI tooling extensions are pulling in transitively. This is the newest and least reviewed part of most AI engineers' stacks. None of these steps are complicated, but almost nobody in the AI ecosystem is doing them consistently. The AI tooling ecosystem is one of the fastest moving software environments in history right now, and that speed creates a compounding security debt. New packages, new plugins, new MCP servers, new integrations, all landing in production environments before anyone has seriously audited them. Attackers are patient. They watch for exactly this kind of gap between innovation velocity and security maturity. The litellm attack was a warning shot that happened to misfire. The next one will be written by someone who learned from this attacker's mistakes, and we won't be as lucky. Start treating your AI dependencies like the critical infrastructure they actually are.